These are the hard problems, okay? And I want to know, did anybody get number 1 correct? Wow, let's hear it. C. Anybody else? C? C? Wow. We are brilliant. Yay. All right, let's talk about it real quick. All right. Now, again, listen to me for a quick second. All right. What does y equal? 5x, right? Y equals 5x. That means wherever I see a y, I can put what? 5x. That's correct. And if I do that, if I plug 5x in for that y, I get 2x plus 5x equals 7. Do we agree with that? And so now what? 7x equals 7, so x is equal to what? Beautiful. X is equal to 1. Anybody have a problem with that? What? What's 5x plus 2x? Yeah, today that's 7.
Oh, that's simple.
Yeah, it was simple. All right. Everybody good with that one? All right, now I'm pretty sure everybody in here got number 2 correct. I'm pretty sure. That was kind of too easy for us. What did you get? E, 1/3, 1/3, 1/3. I don't need to say anything about that, right, guys? 1/3. Very good. Pat yourself on the back. It feels great to be brilliant. All right. Number 3, a little bit more challenging. B. Somebody else? B. Do I need to discuss this? Oh, I got a C. So let's see. Ratio is a fancy word for what? Fraction, right? So I'm going to write a fraction with these. 8 over 3 is equal to 24 over what? And so what do I have to do? What did I do?
Multiply 8 times 3 to get 24. Multiply 3 times 3 to get 9.
You are brilliant. Exactly. Look, we're just doing fractions, right? So 8 times 3 is what? Therefore, 3 times 3 is? You agree with that now?
Oh,
All right, there you go. Good. All right, let's see if I can get something a little bit more challenging. All right, if you got number 4 right, I'm pretty impressed. Yes. C. Wow. Wow.
C.
You sure?
Yeah.
We're happy with C, right? Wow, that's pretty good. Anybody want me to explain it? Go. Tell me how to do it.
Oh. So you have to split the area, you have to times height, and to find that C is 4 on the x-axis, so on the bottom it's 4.
You are amazing.
And then on the top, the y-axis is.
That is exactly correct.
Oh, so that's 4 times 3.
Wow, that's brilliant. Very good, guys. Yes, ma'am. Yep. I always throw a couple questions on there. Try to throw you off. All right, just a little bit of challenge. All right, you don't have to worry about it. All right, is everybody happy with number 4? Yes.
Is the test on Wednesday?
Yes, Wednesday. All right, here we go. Number 5. Ooh, these only were for the thinkers. This was only for the thinker. What? A. E. What did you get?
B.
What?
E.
Why?
Wait. Because what cannot be in the miles? So you know that if you add those up, it's 9. And maybe if you ran it in a different route, it could be like lower than 9. But 10 is way over 9.
Very nice word. That's way over. Way over. That was good explanation, actually. Does everybody understand what he's saying? So look, what I want everybody to do now is from A to B, we know is 5, right? Now, from B to C could be what? Could be 4. Does everybody agree with that? But did I have to go in that direction?
No.
I could have gone what? Straight down. I could have gone over this way. I could have gone over this way. What shape am I actually making?
Oh, a sun.
No, a what? Sun is a... It's going to be a long 3 years for me. I can't even imagine. All right, here we go. So we're going to try this here. We're going to make a circle. There we go. So now, if C is somewhere, if C is somewhere, C is going to have to be moving where? Around the what? Around the circle, right? So what's the absolute farthest C can be from A? You're right. 9. What's the absolute closest it can be? 1. So if I move this direction, I'm getting smaller, right? The distance, right? Distance still getting smaller. Now it's the closest it can get. Now if I go around this way, now it's getting what? Further away. Very smart, guys. You really have. All right, correct answer then was E. It can be anything between 1 and 9. It can be any distance between 1 and 9. All right, just not greater than 10. Tell me.
So I understand that, I understand that's 10, but how do you know that's in a straight line, or how do you know what direction?
That's what I'm showing you. Very good. So watch this. All right, what I want to do is, for you, I'm going to try to draw, I'm trying to grab this C. All right, so here we go. I'm going to try to grab C. All right. Now, C is, what I'm going to do right now is I'm going to make a town here, C. You with me? And now I'm going to move the town wherever I want to. All right, so here is C, and I'm going to move it around, maybe. All right, so here's C. Do you agree I can put C anywhere along this path right here? Because why? Because that's still 4 units from B, or 4 miles from B. Do you agree? So I don't know where I should put C. But I know if I put it as far away as I possibly can from A, it would be right there. Do you agree with that? You see that or not? You see it now? That's the farthest it can be.
I still got the answer, but
Now you know, right? You know now? Because again, what I've tried to show everybody is that as I'm going this direction, I'm still maintaining 4 miles from B, right? But I'm getting closer to what? I'm getting closer to A. All right? So remember, this is as close as we can get, which is 1 mile, and this is as far away as we can get. That would be 9 miles. All right? Hopefully that drawing is pretty helpful. All right, here we go. Let's check out the next one. I don't care. What? Wow. E so far. Pretty happy with that. You guys are on it. What did you get? I got a B, E, A, B. I like that. D. Good. Anybody for C? Okay. So now what I want to do now is I want you to think about this. Let's say you're making something and you need a half of a yard. Can you have something less than half of a yard to make? No. So I want everybody to try to listen to what I'm saying now. Because I know we haven't reviewed fractions. That's why I'm trying to see how good you are. All right, so if I need a half of a yard, can I use 1/3 of a yard? Because 1/3 is what? 1/3 is... Okay, so now what I want to do now is, I really want you to concentrate for me. So I learned fractions using, guess what? Pizzas. That's how I learned. That's how I figured it out. All right? So think about it like this. If the three of us ordered a large pizza. All right, would we get enough to eat? Yeah, we can handle that. Now, if we ordered one large pizza and everybody in here got a piece, then what would happen? Everybody gets small slices, right? So the more you divide, what happens? The smaller it is. You agree with me? So if I ask you to take a look at 1/2, if I say look at 1/2 and I say look at 1/3, which one's bigger? 1/2, right? And if I say look at 1/4, still what? 1/2 is still bigger. What is the fraction doing as I put 1/5? Is it getting? It's getting smaller. Put your hand down and listen. All you gotta do is listen right now. So that's one thing I want you to remember. The more you divide something, the smaller the number is. All right? So I couldn't do 1/3 because 1/3 is what? Less than 1/2. Do you agree with that? All right? Now, I want to see if you can remember this. I want to talk about 2/5. Is that more than 1/2 or less than 1/2? What is it?
Less.
Less. Now, what would be exactly half if I had a 5 on the bottom? What would be exactly half? Yes, you're brilliant. 2.5 would be exactly half. Does everybody see that? So now 2 would be what? Less than half. Does everybody agree with that? All right. Now, what I want to do now is, so we know it's not A or D, correct? Now the question is, can you visualize 3/5, 3/4, and 2/3? All right. Now keep in mind, I need as close to 1/2 as I can be. All right. Even though I'm going bigger than 1/2. So the question is, which one is bigger than 1/2 but closest to 1/2? What is it? Let's see if you're correct. All right. Now, what I tried to do in the last class was I tried to just make a quick little demonstration. And then I really think you guys, I'm going to copy this, paste. Now, I want to draw 3/4. I think drawing 3/4 is kind of easy. So to draw 3/4, I just cut it in half and then cut it in half. Did I agree with that? And then 3/4 would be this physical representation. Did I agree with that? I know you know that. All right. Now I'm looking at 2/3. 2/3 is kind of an easy one to draw because it's like a peace sign. So we go straight down, and then I go over here a little bit, then I go over here a little bit. And so this would be what? 2/3. So what is better, 2/3 or 3/4? 2/3 is better, right? Because 2/3 is closer to what? 1/2. Did I see that? So now I have to check out, so I'm going to cross out 3/4. Now I've got to check out 3/5. 3/5 is a little bit harder to draw, but I'm going to see if I can do it. So you see if you agree with me. Not too great. I'm going to fix one of them. All right, that's pretty close. And so now if I do 3/5, I'm talking about this. So now we're looking at these two right here, guys. Do they look pretty close? They look kind of close, don't they? Right? They look kind of close. Does anybody know which one is better, though? Which one would be better, do you think? B, because it's only 0.5 away from a half. Okay, so let's do this. So you are correct. B is the correct answer. But what I want to do now is I want to see how much you remember from last year as far as your decimals. Does everybody remember 1/2 is 0.5? I know everybody knows that. But what's 2/5? Remember what decimal 2/5 is? Anybody? If you have 2 out of 5, does everybody agree you have 4 out of 10? Does everybody agree with that?
Yes.
So 4 out of 10 represents what decimal? 0.4. Good. 3/5 is what decimal? 3/5 is how many tenths? Yes, 0.6. Beautiful. If I have 3/4, I have how much money in my pocket? 0.75. And now here's the one that most people don't remember, but 1/3, what was that? Yay, I'm proud of you, girl. 0.3 repeating, that's very important. And now 2/3, if 1/3 is 0.3 repeating, 2/3 is? Yes, 0.6 repeating. That's exactly correct. I'm really impressed with you guys. 0.6 repeating. Does everybody agree with that? So now which one of those numbers is closer to 0.5? 0.6. Because 0.6 repeating, this number is a 6, and this would be a what? 0. Does everybody see that now? All right, now ask your questions because I don't want you not to understand something. And the numbers are easy. I'm trying to help you understand numbers better. So if I'm not saying something you understand, you got to ask. What? Okay, because do you remember in 4th grade, you started doing fractions. What was 4/10 the same? Literally, 4/10 is what? 0.4. Right? Come on now, we got to think back. It's been a long time. So how do I read the decimal 0.4? What is that? Yeah, now you're clicking, right? 0.4 is the number 4/10. And 4/10 is the fraction 4/10. That's literally what that means. No, I don't want to times it by 2. I'm trying to tell you something. 4/10 means what? 0.4, which is the same as 4/10. You agree? And 4/10 can be reduced to 2/5. Yes, ma'am. Yeah, percentages. That's good too. All right? Percentages are good too. All right? But I want everybody to understand what I'm saying now. Just like I think everybody here should be able to tell me 3/4 automatically what? 0.75. There's no reason why you can't tell me that. Now, those of you guys who look a little puzzled now, I know you're looking puzzled, which means you don't understand what I'm saying, which means you're not asking me a question when you should. So get your hand up. What?
I don't really get how 0.6 is closer to 0.5 than 0.2.
It's not. It's exactly the same distance. But you're not allowed to have less. It's like I said, if I needed $1 to buy lunch, and my mom gave me 90 cents, was I going to have enough to buy lunch? No. But if she gave me $1.10, I would be good. Right? Yes, ma'am. Good.
I think it's
Yeah. There you go. That's perfectly fine too. All right. So you're comparing, in other words, 1/2 and 2/5, right? Kind of like that. And you did 5 times 1 and 2 times 2. So this was 4 and this was 5. Yeah, that's good. We're going to review all of it. Very good. Yes, ma'am. Okay. So now watch this. It's kind of like how I did A. So you ready? 3/5 is the same as 6/10. Do you agree with that? Right? And 6/10 is the same as 0.6. Same thing. Right? Anytime you can make it over 10 or over 100, it's easy decimal. Right? Just like if I said to you guys, 45/100, what's that decimal the same as? 0.45. Right? The same principle. Okay? Yes. Okay, so we're going to get to the fractions, but I'm just going to show you this real quick. All right? What was really cool to me was 1/9 is 0.1 repeating. Did you know that? 2/9 is what? Math is all about patterns. You with me? So what do you think 3/9 is? But 3/9 reduces to what? 1/3. See it now, right? So these are some things you're just going to know. You just know. Now, you may have forgotten them. I'm not saying that. I'm saying I'm trying to help you remember that. You with me? And most people, if I asked most adults what 1/9 is, they'd look at me crazy. They wouldn't have a clue. Right? 2/3 is the same as 6/9. So, just a minute. So what's 2/3 the same as? Yes, which means it's what decimal? Yay, 0.6 repeating. You have me on this? Right? It's kind of weird how there's going to be lots of patterns. All right, and I'll show you how to mentally do things in your head that most people are like, how did you know that? Right? Because I understand patterns. That's it. All right? So I want you to know that how did I know 1/9 was 0.1 repeating? Because we can do the number. 9 goes into 1.0, 0.1, and it just keeps repeating, right? So it's just 1 repeating, right? And so then I did what? I did 2/9. And I found out that it was what? 0.2 repeating, right? So then I said, wow, how cool is that? Now I know 1/9 all the way to 9/9. And this is something I'd want you to ask your parents. So you guys tell me, what's 7/9, everybody? 0.7 repeating. What's 8/9? Okay, now the hard one. You ask your parents what 8/9 is, and then ask them what 9/9 is. What do you think 9? Yeah, but if it's a pattern, what? It should have been what? It should have been 0.9 repeating. Right? It's very weird things in math come up with when you're doing patterns. You almost reach like contradictions. And believe it or not, which I had a big argument. I can remember arguing with my math teacher all the time. How is 0.9 repeated equal to 1? Right? But believe it or not, 0.9 repeated is definitely 1. I can prove it. Even though I don't think it's true because my mind says 0.9 repeated is not the same as 1. Everybody agree with what I'm trying to say, right? So up here, I'm showing you that numbers, there's a lot of patterns in numbers. And you don't know the patterns right now, but I'm going to try my best to show you. So when somebody says to you, what's 2/3, you don't have to think about it. You just say, well, that's just 0.6 repeated. Well, how did you know it? And then they're going to say, well, what's 1/9? And you say, well, that's 1 repeated. All right? Just like there's some other really cool patterns. Like if I said to you, what is 31/99? Some people think I'm weird. But it's not that I'm weird. I'm not doing any math. I just know the patterns. Guess what 31/99 is? 0.31 repeating. Right? So if we had calculators, I'd show you 31 divided by 99 is 0.31 repeating. So if you know the pattern, that's what? Easy. But if you don't know that, then you look like, wow, how does he do that? Right? So now if I said what's 475/999, you would just tell me that's what? Wow, not many people know that. Right? That's all it is about patterns. Right? So that's where we're at. All right? I'm going to show you lots of cool patterns, lots of cool things. That's why when you're sitting there with a funny look on your face, I know you're not understanding me. Right? So then if you're not understanding, just put your hand up and say, I'll try to explain it a different way. All right? Now, does everybody understand the fractions now? Right? That's a fantastic review of fractions. All right? So now, this is on here again. On standardized tests, these are kind of things that are out of the ordinary. I'm not going to teach you this. You're expected to reason through. All right? So if you're at a $100 Coke and you buy it for $85, what was the percent discount? 15%. So then you write 15% down right here. Now, if you have a percent reduction of 85%, what's left if you do something by 85%? Tell me. Well, not $15, but 15%. I know what you meant. And so if that's 15%, 15%, then what is my answer? Well, hold on. Tell me what my answer is first. C, because the quantities are both what? They're both equal. All right? And this is on your ERBs. It's called quantitative comparison section. We can improve a bunch in that area. All right, now ask me a question. Oh, for column B? Yeah, I know, it was kind of confusing at first, so I can understand that. So what they're saying is, if you reduce something by 85%, how much is left? Just 15, right? Because you normally start with what percent? 100. If I take 85% away, you're left with what? Beautiful. That's it. Quickly.
The game I still have the same answer. I did 85 is 85% of 100.
Yeah, that's exactly correct. That's a good way, right? But listen, I would hope you would say to yourself, well, I don't really need to do that because I'm starting with the number what? I'm 100, right? So a percent literally means out of 100. Quickly.
Doesn't it say the percent reduction on it? So
Yes. So I see your point. I definitely see your point. Yeah, because well, I think they're talking about the percentages what they're trying to get. All right, so if there's some confusion, I understand. Yes. Okay, so can you tell me what a percent means? What does the word percent mean? Out of 100, right? So if you start at 100 and you go down to 85, what percentage you go down? That's the answer to the question. See how that now, right? Okay, that's what that means. Right? I think that's what they're talking about. So those of you guys who are saying B doesn't make much sense to me, I can totally understand that. All right? But I'm trying to tell you that's exactly what they meant. All right? Whether that makes sense right now, it doesn't really. All right? So you just have to take my word for it. A percent reduction of 85% means that you're left with what? 15%. Good on that?
Oh, okay.
That's all it is.
If you take off 85%.
That's exactly right. All right, so now we got a few more minutes, so let's go ahead and talk about this. Oh, this is a good one. This is a good one. So it says, when Gina was 10 years old, the price of a certain item was $100. The price of the item when Gina was 12 years old, or $100. Tell me. Oh, I like this. It's what? D. What did you get? I didn't say that was right. That was an answer. D. All right. Everybody's agreed. D. Because some things, as they get older, they go what in value? They go up, and some things go what? And some things go down. All right. Everybody understands that, correct? Yes, sir. Well, did you understand what I just said?
yes.
Sometimes, for example, you guys see the price of gas, right?
Oh, yes.
Sometimes it goes what? And sometimes it goes up, sometimes it goes down. So just because it's in the future, we can't say whether it goes up or whether it goes down. Right?
It's kind of like a rare baseball card.
Yes, exactly right. If you're buying a baseball card, a really rare baseball card, back in the good old days, it was probably a penny. Now it might be worth $1 million, right? And then there's other things where you buy a car, and now after you buy your car for 4 or 5 years, the value goes what? Goes down. All right, you guys understand that. All right, so here we go. Now, listen right here. This one's a little bit harder because we haven't talked about negatives, but I know you guys talked a little bit about negatives last year, so I'm thinking you can do this. Now, tell me, what's the answer? I said A. What did you get? A. D. I like that. D. D. Good. Good for you. Glad you said something. I mean, what? A. A. You haven't said much today now. You've got to get involved. All right. I put D, so let me see what the right answer is. Oh, we got somebody who knows the answer. Tell us.
Okay, so I thought I knew it because it says x minus y, and y is a negative number, so I think it's x minus a negative number, so it's 2 minus x, so they would cancel out.
I could not have said that any better myself.
What?
I could not have said that any better myself. When she said that exactly right, x minus a negative, right? So if it's x minus a negative, it's going to be what? A positive. So this column right here has to be a what number? Has to be a positive number. Has to be a positive number. And a positive compared to 0, which would be greater? Which would be greater? Positive. Correct answer, kiddos.
So I put A first, but then I put B because it says Y is a negative number, so I thought like they put X minus Y because it's a negative number.
No. That's a good thought, though. Listen, she said something really important. I want to tell you. Look right up here, please. This negative or minus has nothing to do with Y. You with me on this? Has nothing to do with that. But that's a good thought. All right? Very important. Very, very important. That's okay. You're good. You can ask me that.
Can you show me how you did it?
Yes. So look, here's what I want you to say. Someone give me a positive number.
Oh, 5.
5. Somebody give me a negative number.
Negative.
-3. All right? So if I didn't know something, what I do is I always tell kids, plug numbers in. And when I plug numbers in, I'm going to get what? 5 minus -3.
Because when I saw only one minus sign,
That's what they were saying. All right? You see what I'm getting at, right? So that would be double negatives, and double negatives become a what? Positive.
and
Yes.
I'm pretty sure for multiplication, if it's like negative and positive, it would become a negative.
Right. When you're multiplying, yes. All right, guys. Now, this is something some of the kids said they didn't know this. All right, so let me ask you this. How many degrees in a circle?
360.
180 is halfway. So all the way around the circle is what? 360 degrees. You with me? So if I do 25% of that, it's going to be how many degrees? 90. Very good. So what's true? They're what? They're equal. Two quantities are equal. Everybody happy with that? Everybody good? All right. Now listen to me, because we got a few minutes. I want to stop the video now. And what I want to do is I'm going to pass out the review that I want to talk about real quick, okay? This I'm going to call you to my desk and you're just going to show me real quick, all right? But I want to pass out